Did you get food or did you just grab? This one passed. Yeah. I got it. Sorry. There's actually I never see your end. Oh, I haven't turned that on. So when you finally get me see something. I want to go and do what? I want to go. Turn that back on. Something else. That's in my. Ugly. You have these. If anybody else. Okay, folks. So we are going to go ahead and get started first with the announcements as per norm. You do have, I think it's like 5 ed puzzles. One of them's 12 minutes, but most of them are pretty short, I believe, if I recall, that are related to the laboratory that are due tonight at 11:59 p.m. If you'll recall, as part of your laboratory grade, there is a quiz at the start of lab. It will come from the background, so make sure you read the background associated with your lab before you come tomorrow. I plan to get homework 4 up on active this afternoon. Since we didn't have class on Monday, there was nothing to, I figured I'd wait till today because it would be related to today's information. So I will get it up, and as a reminder, that is due on Sunday at 11:59. Obviously, quiz days, there are no tests. Test days, there are no quizzes. So just as a reminder, we will pick up with quizzes again on Monday. I also plan to return your exams on Monday. One of the things I will guarantee you, while I can't promise exactly when I'll get laboratories back, normally it's within a couple of weeks. But while I can't promise when I'll get those back, you will have your exam no more than 1 week after you take the test. So the things that are worth the most, I do prioritize when I'm grading. And then the other thing I wanted to make note of, because I forgot here when I was talking about the lab, is I cannot remember if there's a pre-lab in your packet. If there is, I don't take a pre-lab, so you don't need to worry about the pre-lab. So, questions? Now, before I get started into today's lecture, I did have 2 questions. First of all, I want, and this, obviously, I don't want to put you under pressure, but if you did my optional homework, raise your hand before the test. If you were surprised, keep your hands up. If you were surprised by what the test looked like, keep your hands up, otherwise put them back down. Folks, that's what I was trying to prove. if you do the optional homework, you're not gonna have surprises typically on my exam. There may be one or two questions that might catch you off guard. But as a whole, you're gonna know what my exam looks like. And I know that first exam is always scary for students. But I wanted you to understand just how, when I say do the optional homework, I mean do the optional homework so that you're ready for the exam. Any questions about the exam other than how you did? Because obviously I don't know. All I can do is try to be straightforward with you. That's all I really can do. Okay. Then we're going to get into what is probably the toughest part of chapter 13. Oh gosh. Monday before the ice storm. We had started going over units of concentration. And all I've done is condense all those units of concentration down onto this one little slide. So you've got your molarity. You've got your percent concentrations that can come in the form of mass, volume, mass, volume. You've got your parts per concentration, such as parts per million, parts per billion, and parts per trillion. You have mole fraction. All of the ones that I have written above this angled line, they're always going to be solute over solution. The exception I tried to make note of by writing it in a different color, but the dynamics aren't quite as good. And that is molality. Molality is mole solute over kilograms of solvent. Now, I also added 3 other equations up here because those 3 other equations are going to play in to converting from one concentration unit into another. So you'll need your density at some point to do some inner conversions between some of these. You'll need the fact that a solution is equal to its solute plus its solvent, and you'll need the molar mass. So this is again, I mentioned that card, which hopefully some of you took me at my word. That card that you should probably have all these, or that single page where all of them are written so that you can easily find them. Because as you work through problems, it's going to come in handy to know the various units of concentration. Now, folks, converting between concentration units can be very challenging. But that challenge can be simplified if you are constantly asking yourself, what do I need in the numerator? And what unit do I need in the denominator? Because as you're performing these conversions from one unit of concentration into another unit of concentration, the easiest way to perform these conversions is to take the numerator and convert it into the numerator. Because in all cases, except for mole fraction, it's all about the solute. And then you take the denominator and convert it into the other denominator. Once you have got the numerator in the correct unit and the denominator in the correct unit, then you combine them into their formula to make the concentration unit. Now, folks, I know you can't see this, but I actually tried to think through all of the different calculations I had to do to these conversions. To go from molarity to molality, I'm going to have to convert the denominator of liters of solution into grams of solution using the density. I'm going to have to convert the moles of solute into grams of solute using molar mass. And then I'm gonna have to use the fact that the grams of solvent is equal to the grams of solution minus grams of solute. Just to get all the pieces to go back into the equation. There's actually 5 calculations that have to be done to take a molarity and convert it into a mole fraction. There's 4 calculations to convert a mole fraction into a percent concentration in the mass percent. In other words, these aren't easy, so you really do have to do what I just said, where you have to think, what is my numerator? Okay, what calculations do I have to go from this numerator to that numerator? What is my denominator? Okay, what calculations do I have to go from this denominator to that denominator? You're gonna have to puzzle it out. Because it is quite, I decided I could not draw something to give you like a flow chart. Because it gets that complex. I mean, I can, but I'm gonna need a bigger poster. And maybe I'll try to do it on a regular poster and let you take a photograph. But it was getting challenging on a sheet of paper. And I don't have big handwriting. So, okay. So what we're going to be primarily focused on today is actually doing calculations. That is my goal today, is to perform calculation, give you a calculation, perform another calculation, and we're just going to be doing nothing but concentration calculations and converting between them all day long. Okay. So, let's see, a commonly purchased disinfectant is a 3% by mass, so that would be a weight percent solution of H2O2 in water. Assuming the density of the solution is 1.0 gram per centimeter cubed. Calculate the molarity and molality of hydrogen peroxide. Okay. So the first thing I want to just do is discuss this percent composition and how I normally can think of these percents. So when I have a 3.0%, that came out from being a grams of solute over grams of solution times 100, correct? That's the formula. Now, when I see this, I see, okay, 3%. I can get that 3% by going 3.0 grams of, in this case H2O2 over 100 grams of solution times 100. And let's face it, that would cancel out and I'd be left with 3%. I'm saying because these 100s would cancel and leave me just my 3. I'm saying this, what because you'll see me when I'm given a percentage, I will just start out as 3.0 grams of H2O2 over 100 grams of solution, and that's where I'll start. And I wanted to explain why I'm starting there. Okay, so I have been asked to convert that into first molarity. Molarity is going to be mole solute over liters of solution. I am going to begin and I am going to work with the numerator separate from the denominator. So I'm going to take that 3.00 or 3.0 grams of H2O2, and I need to get that into moles of H2O2. And we do so using the molar mass of H2O2. So 3.0 grams H2O2, the molar mass of H2O2 is going to be 34 grams per 1 mole. And keying that into the calculator, that means we have 0.0882 moles of H2O2. The second part of this is I need to convert that 100 grams of solution into liters of solution. Now, anytime you have a mass and a volume, one of your conversion factors is going to be the density. So we're going to take that 100 grams of solution and we're going to use the density that they gave us, which was 1.0. That was 1.0 grams of solution is equal to 1 centimeter cubed of solution. And a centimeter cubed is equal to a milliliter. And then we can use the metric prefix conversions to get that into liters. Which should be 0.1. Now to get to the molarity, again, my molarity is moles of my solute over liters of my solution. So that's going to be equal to 0.0882 moles of H2O2 divided by 0.1 liter of solution. And that gives us a concentration of 0.882 molar H2O2. Questions? Mhm.
Can you do all this more stuff?
You can now, because this question also asked for the molality, it's easier to do it in two because molality is moles of solute over kilograms of solvent. So you're going to need to break it apart eventually. But yeah, I mean, technically you could have done it all in one. It's just with these concentration units, I find most struggle with that. So if you don't, fine. Yeah. Well, yes, because you're going to wind up using those moles you calculated for something else. So. Okay, now, which actually brings up a very good point. The question, as soon as my computer wants to give me, thank you. Not only asks for the molarity, but it asks for the molality. So you also have to calculate the molality. So we're also taking that 3 grams of H2O2 to 100 grams of solution. And we have to convert that into moles of solute, in this case, H2O2, over kilograms of solvent, which in this case is water. From the previous problem, we've already done the numerator. We've already converted the grams into moles. So we can use that 0.0882 that we calculated earlier. But we still need to deal with the denominator. And this is where it can be, where you have to think of what you're doing. The difference is in the denominator, we're starting with solution, but we need solvent. We need just one piece of that. And what we know is that if we take our grams of solution, that's going to equal the grams of solute plus the grams of solvent. From our original concentration, you already know you have 100 grams of solution, and that was equal to 3 grams of H2O2 because that was in our original value as well. So that allows us to calculate the grams of solvent, which was water. So we have 97 grams of water. You take that 97 and you convert that into kilograms. And you get 0.097 kilograms of water. You now have the denominator you needed. So we're ready to calculate our molality. Our molality is mole solute, which was the 0.0882 moles of H2O2, divided by our kilograms of solvent, which is 0.097. So you get a 0.909 molal H2O2 solution. Now, looking at your molarity, it was 0.882, whereas the molality is 0.909. Why would the molality be higher than the molarity?
exactly. Molality is always going to be slightly higher than the molarity because in the case of molality, you're only dividing by the solvent. And while that is the major component, in the molarity, you're dividing by the entire thing. Questions? Let me give you one to work on. What is the molarity of muriatic acid which is basically a 38% by mass HCl solution in water. And that solution has a density of 1.19 gram per milliliter. Molar mass of HCl is 36.45. Molar mass of HCl is 36.45. HCl. It's just HCl. It's just HCl in water. It's just a specific concentration. It's just hydrochloric acid at a specific concentration. It's an old name for it. Okay, anybody want to walk me through what to do? One step at a time and each step be somebody different. Somebody else who told, how do I convert grams to moles? What is the unit? Thank you. And let's see, I have this number. Somewhere. Worked all this in advance. 1.043, okay. Next. Liters of solution.
It's 100 grams and then 1 milliliter. 1 milliliter over 1.19 gram. One liter to 1,000 milliliters.
And that comes out to be 0.0840 liters. And then I now have my two components. So it'd be 1.043 moles over 0.0840 liters of solution, which comes out to be equal to 12 molar HCl. Also known as muriatic acid or conch HCl. That's as strong of a concentration of HCl as we get. So if you're ever working with conch HCl or concentrated, it's 12 molar, you're working with muriatic acid. Muriatic acid is just an old name. No, that will not be incorrect because I only in lab am I going to pay attention to sig figs. So if you're just, as long as you're real close to whatever I have, you're going to be getting your credit. Questions? How'd it go? Okay, well, let's change a pace a little. What is the mole fraction of sodium hydroxide? No, excuse me, sodium phosphate. In a 0.142 molar Na3 PO4 aqueous solution that has a density of 1.015 gram per milliliter. Okay, so if we have a 0.142 molar solution, it's 0.142 moles of our sodium phosphate to 1 liter of solution. We have been asked to convert that into the mole fraction, so we're going to need moles of sodium phosphate over moles of solution. You already have the numerator because we wanted moles and we've got moles. It is the denominator that we're going to have to do some work on. Because we have liters of solution, we want moles of solution. So liters is a volume, moles is an amount. So we've got to convert volume into an amount, and that's where the density is going to come in. So you're going to take that 1 liter of solution, and the first thing you've got to do is you've got to convert that into milliliters of solution. So that you can use the density that was given of 1.015 grams of solution is equal to 1 milliliter of solution. So that's going to be 1,015 grams of solution. Now, folks, you cannot convert grams of solution directly into moles of solution because everything has its own unique molar mass. You don't have a molar mass of the solution. So what that means is I'm going to have to convert this to get this grams of solution into the moles I'm going to need. I'm going to have to take and understand that the grams of solution is going to equal the grams of solute plus the grams of solvent. And I'm going to need to get both components here. I'm going to need to get both of their masses and add the masses together because the masses are additive. Molar masses are not additive. Masses are additive, but molar masses are not. So I'm still going to have to mess with that 0.142 moles of sodium phosphate and get it in grams. By using its molar mass. Which is right at 164 grams to 1 mole. So in other words, the sodium phosphate contribution is 23.288 grams. You know that the overall solution, there was 1,015 grams of solution. And that's going to equal the 23.288 grams of Na3PO4 plus X grams of water. So you can get your grams of water. My brain would work, it'd be nice. And you got 991.7 grams of water. Yes. If I don't give you a solvent, assume it's water. If it's anything but water, I will give it to you. Folks, one of the things that's easy to do is get lost in what you are still trying to solve for. Remember what we're looking for. We need moles over moles. So we got to get this solvent into moles too. With the fact that there's 18 grams of water per every 1 mole of water. So we have 55.095 moles of water. Just like grams are additive, the moles are additive, just not the molar masses. So our moles of solution is going to equal the mole of solute plus the mole of water. So that is 23.288 plus 55.095 means that our moles of solution is 78.383. I'm sorry, that is not right. Thank you. I was actually looking at that number going, something's wrong. So thank you. 0.142 moles. So 0.142. Equals 55.237 moles of solution. Now you can finally answer the question. The mole fraction is going to equal the moles of the sodium phosphate over the moles of solution, which means it's going to equal 0.142 divided by 55.237. And that gives you 0.00257. And mole fractions do not have units. Now, if I wanted to know the mole fraction of the water, that's easy at this point. Because the mole fraction of the sodium phosphate plus the mole fraction of the water has to equal 1. So since you've already got the mole fraction of the sodium phosphate, it's not hard to calculate the mole fraction of the water since all of it has to equal 1. break time for 3 minutes, 3 or 4 minutes. It gets daunting quick. I mean, I find them fun once you get used to them, but. You want to go say hi? You want to go say hello to people? When you get up and about, you go say hello? Let's go make our round. It'll be about get back to say hello to everybody. They go say hello. Say hello. Say hello to everybody that wants a little pet. They're not talking about it. Anybody else need some more? The first thing, is there a number? She's like, no, I'm fine. She's not there.
Puppies grow. I was gonna say, it's Back in the bed. Back. There you go. Such a good girl. Okay. So let's see what I can find you. So why not? That and all work. Calculate the molarity, I'm sorry, excuse me, the molality, the percent by mass, and the mole fraction in a 7.576 molar NaOH solution whose density is 1.265 grams per milliliter. And I am going to give you time to work on this one. And Luna's going to come around some more. Because this really does take practice if you can't guess. It's kind of tricky. You want to walk some more? Let's go help our students. Let's go help them. Let's go see. And y'all can work together too, don't forget. It doesn't have to be a quiet process.
You already had the mold of the name.
Yeah, most of the.
Oh, you have to sign, yeah, you just have to.
Oh, shit. I thought I was missing something. I was like, this is too soon.
Now you're not far. So I just sit.
You're such a good girl.
Yeah.
Sorry, I found this one.
Oh, it's okay. But thank you.
Yeah, because I didn't round. If I round something.
Okay, I've got the answers on the board. Of course, if you were watching me, was working it while you were working it because I didn't have the answers written down. So I had to do it.
So the very first one is 7.876 molal. Again, you will notice that the molal is slightly higher than the molarity, which was 7.576, I believe it was. It was 24% sodium hydroxide, and then the mole fraction of the sodium hydroxide is 0.124. Which means that if I wanted to know the mole fraction of the water, which we will eventually want to know, we're not interested too much at this one, but that would be 0.876. So let me walk you through what I did because I want to make sure and the reason I was going ahead and doing it is I want to make sure I had time to walk you through the pieces before class let out. So the very first thing I did is I took that the molarity given, and I basically converted it into its subcomponents. So it's 7.576 moles of sodium hydroxide per 1 liter of the solution. Looking at that, I want molality. So I got to get to grams because I need kilograms of solvent. So the first thing I did was I took the liter of solution. Well, I should say, let me rephrase that. I wanted molality, so that was moles of solute over kilograms of solvent. So the trick was really getting to the kilograms of the solvent. So I took the volume of solution, I converted that into the grams of solution using the metric prefix conversion factor and the density. So there's actually 1,265 grams of solution. Now, to figure out the solvent alone, that means you have to subtract out the solute from the solution. So before I could do that, I had to convert that moles of solute, the moles of sodium hydroxide, into their grams using its molar mass. So that was 303.04 grams of sodium hydroxide. Then I was able to use the fact that a solution is equal to solute plus solvent to get to the grams of the solvent, which meant the grams of the solvent was 961.96 grams. But you have to keep in mind what you need. I needed moles of solute over kilograms of solvent. So I took that kilograms and that grams and made it into kilograms and then plugged it into the equation to get the molality. You just did the majority of I'd say at least half of the hard work, because once you got all this, the next one I asked for was easy. The percent concentration was super easy to get because you'd already done all the work for it. Because if you want the percent concentration, you need grams of solute over grams of solution. And folks, those were right here in that particular calculation that we needed to do earlier. So to get the percent, you simply took the 303.04 and divided it by the 1265 times 100, and that gave you your percentage, which is 24% sodium hydroxide. Now, the last thing I asked for was the mole fraction. And that's the piece that we didn't have all the pieces to yet, because mole fraction is moles of solute over moles of solution. We already had the moles of solute, but we needed the moles of solution. So what you have to do is you have to take the grams of solvent, convert it to moles of solvent, where you get 53.44 moles of water. And then you add the moles of solute, the sodium hydroxide, to the moles of solvent, the water, to get the moles of solution. And once you have that, then you can plug it into your mole fraction.
questions? Okay, you get a vote. These problems are not fast. Not when I ask for multiple pieces. And even if I don't sometimes. So you need to be confident come test time that you can do these conversions. You get a vote on how many homework problems you have to do before Sunday. 5, 10, and 15 are your choices. You don't want too few, or you're not going to be ready at all. You don't want too many, or it's going to take forever. All those that want just 5 for the homework. All those that want 10 for the homework. All those that want 15. Okay, I got mostly 10s. So there will be 10 homework problems. But keep in mind, you've got the optional homework as well. You can see, and folks, you need to be prepared. On Monday, we're going to start dealing with looking at how the introduction of a solution alters the vapor pressures and stuff like that. And as part of those problems, you're going to have to calculate mole fractions and molalities. So we're going to be using it come Monday. With that, I will have a great weekend. Well, no, I'll see you all tomorrow. What am I saying? I'll see you all tomorrow. You don't have to print out the lab and the majority. You need your data sheet and results and post lab. You've got to print out those pages, but you don't have to print out the entire thing. You can simply bring an iPad or a computer to look at the procedure.
So the version thing that you were working on,